Hello my dear students, welcome to Vignan's Foundation for Science, Technology and Research deemed to be University. I, Dr. M.B.K. Srivani, Associate Professor from the Department of Sciences and Humanities, present here to discuss about ozone depletion. What is meant by ozone? Where it is present? What is the problem? From childhood, we are talking about ozone layer depletion and its consequences. Actually, ozone is triatomic oxygen which is present even in atmosphere, not only in stratosphere. Ozone is O3. Oxygen, it splits into two oxygen atoms. This is just bond oxygen. If this just bond oxygen combines with O2, it forms O3. Okay? This is nascent oxygen. If it combines, it forms O3. So it is formed in the, not only in the stratosphere, in atmosphere this ozone is formed. But it itself destroyed. Nobody go and destroy this ozone. Understood? Again this ozone is absorbed by radiation and again it splits like this. That means ozone itself forms and it itself destroys. Okay, and it maintains balance. But here, due to chlorofluorocarbons, I will discuss in detail. Especially the chlorine is responsible for depletion of ozone or dilution of ozone. That is the problem we are facing. Because of the dilution of ozone layer, the UV radiations B, which are highly toxic, they are entering into the troposphere and causing effects. That's why it is the major problem for us today. So we have to do something to control this ozone depletion and protect our environment. Okay, let us see introduction, causes of depletion, consequences, control measures. Coming to the introduction, ozone is isotope of oxygen. It consists of 3 atoms of oxygen. It is colorless, odorless gas. Where it is present, I told you, I am not talking about its formation. Where it is present, the ozone is present in stratosphere in the form of concentrated thick layer. It is formed even in troposphere, but in stratosphere it is present in the form of layer, ozone. Okay, so it varies from 16 kilometers to about 50 kilometers. From 16 to 50 kilometers, the layer-like structure is present, that is known as ozone. It is playing an important role in preventing UV radiations which are highly toxic. Coming to the formation of ozone, I told ozone is formed itself and destroy itself. What happens now? See, this is ozone. Chemically forms when UV hits on stratosphere. Oxygen molecules dissociate into atomic oxygen. These O2 by UV radiations, they splits like this. Two oxygen atoms, they split O plus O. To form ozone, we require just one oxygen. So this will happen. Oxygen molecules dissociates into atomic oxygen. You can see here, all of you. Let me turn this side. You can see here. Okay. So here what happened? This just bond oxygen. Atomic oxygen quickly combines with another oxygen molecule. See, the just bond oxygen combines with oxygen and forms ozone. This is formation of ozone. Again it destroys. What happens here? Ozone which is formed, this by again UV radiation, it splits into oxygen plus nascent oxygen. This is destruction of ozone. Like this, the balance takes place. Ozone is created as well as it is destroyed in the stratosphere. What are the causes of ozone depletion? We say chlorofluorocarbons. So these chlorofluorocarbons are inert in normal and physical reactions. They are highly stable. They won't react with anything until they are in the troposphere. Understood? Whenever they crossed the troposphere and they reached stratosphere, then what happens? See, when they get accumulated in the higher altitudes, then they release chlorine atoms under the influence of UV radiations. Okay, for example, CFCl3, this is chlorofluorocarbon example. Okay, see here all of you, you can see chlorofluorocarbon example this is. Until in the troposphere nothing happens, I told you. It reached the tropopause. That means here troposphere you will learn in school. Like that in between troposphere and stratosphere tropopause, here stratosphere is present. So whenever it reaches the stratosphere or tropopause, if it crosses its tropopause, then what is present? UV radiations. See, because of this UV radiations, this CFCl3 splits like this. Chlorine will come out. This chlorine which comes out is responsible for depletion of ozone layer. Okay? Now that only under the influence of UV radiations, chlorine acts as a catalyst to destroy the ozone. That is the problem happened. We used long back chlorofluorocarbons because they are not explosive, they are highly stable, they are not toxic. That's why we used. Simply we cannot use this chlorofluorocarbons in refrigerators. Okay? What is CFC? You can see. Composed of elements like chlorine, fluorine and carbon developed in 1930 by DuPont. This is an American based company. They were used in industries because they have low toxicity. I told you they are not highly toxic. They are highly stable. They are cheap. That's why we used these in refrigerators as coolants. We used these in refrigerators as coolants. Coolants, that is the reason we used it. Okay, now understood now? They are very cheap. They are not toxic. They are not explosive. They are highly stable. That's why we used these chlorofluorocarbons as coolants in refrigerators. In refrigerators, in making flexible foam, we are using this chlorofluorocarbons. But unfortunately, problem is created by chlorine. Okay, see, chlorofluorocarbons are used in aerosol sprays. This is the picture. Next, they are used as refrigerants. See, this is a picture. You can see this picture, students. These two. Okay, now coming to the mechanism. Destruction of ozone layer. I will tell you how the chlorine destroyed ozone and nitrous oxides. Nitrous oxides are also responsible for depletion of ozone layer. Okay, let me explain. Listen carefully. Just now I told CFCl3. That means chlorofluorocarbon. Whenever they reached the stratosphere, what I told you? Chlorofluorocarbon become unstable and the chlorine is released. See, by UV radiations, chlorofluorocarbon, CFCl2 is formed. Next, chlorine is liberated. This chlorine went and reacted with ozone. See, let me repeat again. Chlorofluorocarbons absorbed by UV radiation and chlorine is liberated. See here all of you. This chlorine went and reacted with ozone and produced chlorine monoxide. All of you can see this equation. What happened here? Chlorine which is liberated went and reacted with ozone and formed ClO, chlorine monoxide, and oxygen came. So now what happened? This chlorine monoxide then combines with another oxygen atom to form new oxygen molecule and a chlorine atom. So this ClO is there now. This combines with another oxygen atom which is present there, and if it combines like this, again chlorine came. See, again chlorine came. That means the chlorine is not used up in the reaction. If it is used up in the reaction, then the problem can be controlled. What happened? Again the chlorine came. This chlorine again went and reacted with ozone. Again the reaction continued, chlorine monoxide, oxygen. This reaction repeated thousands of times and lakhs of ozone or molecules are destroyed. Understood? See, this chlorine atom is free to destroy up to 100,000 ozone molecules. That's why there is a dilution of ozone layer due to this chlorine. Is it clear for you now, students? After this, let me see nitrous oxides I explained or not. Okay, you can see here, students, all of you, nitrous oxides may be released from industries, from sewage waste, burning of fossil fuels, from fertilizers that are used in agriculture. This nitrous oxide which is released into the atmosphere, what happened? Because of their light weight, they enters into the stratosphere. That is the problem. Because of their light weight, they enters into the stratosphere and release oxygen free radical, and this free oxygen radical react with the ozone layer and convert ozone into two molecules of oxygen. Here it went and reacted with ozone. Ozone is converted into oxygen because of this nitrous oxide. That is the problem. Here also same, you can see nitrous oxide which is released there, it reacted with ozone, nitrogen dioxide came, oxygen came. Again this nitrogen dioxide, it combines with oxygen atom there, and again it produce nitrous oxide. See, again nitrous oxide came. This nitrous oxide again went and reacted with ozone. Here also the reaction continued. So that's why it results in ozone depletion, and this is also responsible for depletion of ozone layer. Okay, this is net. Just oxygen, ozone, two molecules of oxygen is formed. Understood? You can write these two equations. And later, before this chlorine, these two equations. If they ask you to explain the mechanism of ozone depletion, you have to explain how chlorine reacted with ozone, how nitrous oxide reacted with ozone. This is about the mechanism of ozone depletion. This is about the mechanism of ozone depletion. Okay, so now let me explain effects of ozone layer depletion. What are the effects? You know already, it depletes ozone. Ozone is playing an important role in absorbing the UV radiations B, which are highly toxic. If ozone is diluted, then this UV radiations enters into the atmosphere and affect the environment. Clear? Now see, this CFC, chlorofluorocarbon, is stable and has long lifespan. It persists in the environment for a long time. So it continuously attacked ozone layer and more UVB radiations reach our earth. That is the problem we are facing. We are facing what we faced already. Okay? Now you can see. See this, if the UV radiations increases, they causes effects on DNA of the exposed cells of organisms and cause mutations. I told you, sudden heritable changes, I gave example cancer. Sudden heritable changes or mutations, you can write. Okay, sudden heritable changes or mutations, example cancer and also skin cancer. It causes Malignant melanoma, that is skin cancer. I did not mention here. You write down malignant melanoma. It is the skin cancer. Next one, the radiation centers into our eyes. It results in loss of visibility. Other effects are climate changes due to global warming. Chlorofluorocarbon is also responsible for that. You can see all of you, cataract, how the eye became. This is due to UV radiation. Next you can see skin. This is one simple example. Okay, these are the effects, examples, these are the pictures. Okay. Reduce immunity. Reduce photosynthesis in plants because of UV radiation. That is one problem. Planktons. What I told you about planktons? Free floating masses of plants or organisms. They will die due to this heat, due to this UV radiations. Planktons are the food for number of living organisms. I already discussed. Okay, if planktons will die, other organisms which eat planktons gets affected. Right? Next. Reduces penguin population. You can see penguin. Okay. It kills the krill. So this is the food for penguins. Fishes and krill are die due to these radiations. So because of their death, it affects penguin population. See, you can, I wrote here, you can see, let me speak. Warming seas and increased UV radiations have decreased krill availability. You can see this picture, all of you. Let me turn this side. You can see this picture. This is krill, food for the penguin, just like prawn. Okay, we can call it as prawn, but it is one different type. It is also, we can also call it as a prawn. Okay. So next, that is the problem. One of the major food sources for penguins in Antarctica. Okay. Let me discuss the control measures of ozone layer depletion. The only practical solution to the problem is to accelerate and phase out complete elimination of chlorofluorocarbons, because the chlorine is highly responsible for ozone depletion. In order to control ozone depletion, there are many conferences held throughout the world and many alternatives are used. What are the alternatives? Can you tell me here? I can tell HFC. Hydrofluorocarbons are used instead of chlorofluorocarbon. What are the conferences held that discussed about this ozone depletion and how to control? Okay. So now you can see here, Vienna Conference at Austria in the year 1985. This they will ask you for 1 mark. They will ask you for 1 mark. You please note down this. Next, Montreal Protocol in the year 1987. Next one, Save the Ozone Layer Conference in the year 1989 March. Next, Helsinki Conference in the year 1989 May. You have to remember these years. Alternatives, instead of CFC, we are using HFC and HCFC. These are the alternatives instead of chlorofluorocarbons. Here, let me discuss one point, that is Montreal Protocol. See, this Montreal Protocol was held mainly to phase out the use of chlorofluorocarbons to completely stop ozone depleting substances. Montreal Protocol was there. Okay, it was established. Don't write it was held. The Montreal Protocol was established mainly to phase out the use of chlorofluorocarbons. Okay, next one I did not tell you, that is Kyoto Protocol in Japan. Kyoto Protocol was established to stop greenhouse gases. Please remember that. Kyoto Protocol to reduce or to stop greenhouse gases immediately. Montreal Protocol to stop the usage of chlorofluorocarbons. Right? These are some of the references that I have taken from the website. Thank you students for listening this lecture. In this lesson, I covered ozone depletion, causes of ozone depletion, mechanism of ozone depletion, effects of depletion, effects of ozone depletion and control measures. Thank you.